This video is about linear inequalities. First, let's discuss the properties that we have to remember when we are computing for linear inequalities. So an inequality is a mathematical statement that one expression is greater than, or it can also be greater than or equal, or less than or equal to another expression. So here are some examples. So we read this as A greater than B, A greater than or equal to B, A less than B, A less than or equal to B. Please review the inequalities when we are dealing with negative numbers. For example, negative 7 is less than or equal to negative 3. So take note that you don't have to satisfy both of this. So it's less than or it's equal. So if I have negative 7 less than or equal to negative 7, this expression or this inequality is still true. So more on the properties to help us solve for inequalities are the following. Addition property of equality. So when you're adding a number, it can be both a positive or a negative number to both sides of the inequality. This inequality remains the same. So for this example, okay, I subtracted 2 to both sides, to the left side and to the right side, and this sense of inequality remains the same. For multiplication, if you are multiplying by a positive number, then your inequality remains the same. So for this particular example here, we are multiplying both sides by 1/3. So you can also view this as dividing by a number. But when you are multiplying by a negative number, then the sense of inequality will reverse. From greater than, it becomes less than, because the number that we are multiplying here is negative 1/3, or we are dividing by negative 3. Okay. So to summarize this, the only time that your inequality will reverse its sense is when you are dividing by a negative number or multiplying by a negative number. Okay. Next thing, we have to be familiar with inequality and interval notation. So this is the inequality notation, which tells us that there's a number x that is greater than a, but it's less than b. When you write it in interval notation, we use parenthesis a, comma, b, close parenthesis. So in the line graph, that means all the numbers in between a and b are included, all the numbers here except for a and b. For example, if I say x is greater than 1 and less than 2, so that means all of the numbers in between 1 and 2. So it can be 1.00001, as close as possible to 1, as long as 1 is not included. And a number that is very, very close to 2, 1.99999, and so on. So all the numbers in between 1 and 2 are included except for these two numbers. Okay. So here we have x is greater than or equal to a, but it's just less than b. So that means we include the number a, but b is still not included in our value for x. So if you look at the line graph here, so we include a, we have a shaded circle for this, and b is not included. So we can also do the other side, wherein a here is not included, but b is included. So we used bracket for that. And then for this next interval notation, all the numbers between a and b, and we include a and b. So since you have inclusion of A, we have bracket here, and inclusion of B, we have bracket here. So that means if the end number is not included, you use a parenthesis. If the end number is included, you use a bracket. Okay. How about for the following? The following ones includes infinity. So what do we mean by infinity? So there are two types of infinity. We have the negative infinity and the positive infinity. So what's the meaning of negative infinity? This means that this is a very large negative number. So we don't know the exact number of that, but it's some number that is negative with a very, very large value. And when you say a positive infinity, okay, so it's a very, very large positive number. So when we say that x is less than a, okay, so for example, we can say that x is less than 5. So that means all the numbers that is less than 5. So if we draw the real number line, all the numbers on the left of 5 will be included, and we don't know where to stop, right? So we can have like -1, and then all the negative numbers that would be going all the way to the left. So that's why we use this notation. So from negative infinity to a. Okay, so since a is not included, we use a parenthesis. Now, why do we use a parenthesis for infinity? Because we don't exactly know what is that value. So it's not a specific number that we will end up with. So we use parenthesis always for negative infinity and for positive infinity. So this one next is x is less than or equal to a. So all the numbers to the left of a, so negative infinity up to a, and since a is included, we're using a bracket. Okay, so this one is for the greater than. So when you say greater than, you start at a, and all the numbers bigger than a to the right. So this will continue on until a very, very large positive number. Hence, you start from a, but a is not included, so we use a parenthesis up to positive infinity. Okay, here this is a bracket, then up to positive infinity because a is included. So when you see this notation, x, an element of any real number. That's how you read this. So when you write that in interval notation, that means it can be any of the numbers in the real number line. So it would be from negative infinity to positive infinity. Okay, so we're ready now to solve for linear inequalities. The rule will be similar to solving for linear equality. You try to put all the ones with variable on one side and all the constant on the other side. Usually, we have all the variables on the left side and all the constants on the right side. But you can also do it the other way around. So what I'm going to do is I'm going to transpose. That's a term that we use commonly. Okay. And then I'm also going to have all the constant on this side. So this is, since this is -3, when we transpose this, this becomes +3. Okay, the next step is just going to simplify things. So 8 minus 3, 5x. 5 plus 3 is 8. So we divide both sides by -5. So since this is positive 5, since this is a positive number, then we're not going to change our inequality. So you can write your answer, final answer, in this notation, inequality, or if we use the interval notation, it's less than 8 over 5. So it's from negative infinity up to 8 over 5. So since we have an equality here, we're going to use the bracket. Okay. Second example, if you don't want to deal with fractions, what you can do is you can multiply by the LCD. So by doing that, you'd be able to get rid of this fraction. So what are the denominators? So let's look at the numbers in the denominator. We have 12 and 4. We're going to get the LCD of 12 and 4, and that would be 12. So we're going to multiply both sides by 12. Okay. So since this is one term, there's only one term here. So when you multiply 12 and 12, this will cancel out. So you'll just have x plus 10, since this will just be 1. And then for this side here, if we multiply 12, let me just write it down first. So that's 2x minus 3 times 4 times 12. So you can see the steps clearly. And then here we have 6 times 12. I'll just copy the left side. And you will see here that you can simplify 4. 12 divided by 4 is just 3. So instead of multiplying this, so you multiply by 3. Don't forget to distribute 3. So that's 3 times 2, 6x. 3 times 3 minus 9. And then the constant here, 6 times 12, that will be 72. Okay. Then again, all the variables with x, we have that on one side and all the constant on the right side. So that's x minus 6x. And then this will be negative 10 minus 9 plus 72. And then we simplify. We have negative 5x. And this one, if we simplify this, 72 minus 19 is 53. So we're going to divide both sides by negative 5 because we want to have x here. Okay, now take note, you are dividing by a negative number. So the sense of inequality will have to reverse. So this becomes 553 over negative 5. And when you write this down in interval notation, since this is less than, again, this is negative infinity up to 53 over negative 5. But we're going to use parentheses because this number is not included. Another example here. So this is a little bit different because you have 3 terms. There are constant on the leftmost and on the rightmost side. So what we want to do is to have x on the middle. So we're going to try to get rid of this constant by adding 4 to all of the sides. X minus 4 plus 4, 6 plus 4. Then simplify this, so you'll have 2. And then this negative 4 and 4, this is our goal to get rid of negative 4. That's why we added by 4. So we'll only have 3x in the middle. And then on this side, you'll have 10. So since our aim is to solve for x, we're going to divide not only the middle, but we also have to do that for all of this. So divided by 3. So our final answer would be 2/3 less than x less than or equal to 10 over 3. Since we are dividing by a positive number, so we don't have to reverse the inequality. This is positive. But if there are instances that you have this type of problems, let's say that's negative x and you have negative 1 to 5, and you need to divide by a negative number, then you have to reverse your inequality. So what happens if you don't reverse that? It won't make sense. So this is wrong. If you don't reverse that, you'll have 1 less than x less than negative 5. Okay, so this will still make sense. Like you can still find numbers, right? But this is not the solution to those that will satisfy this expression here. So this is not the correct answer. This should be this one. And we just have to rewrite this because we always have the small number on the left side. Since negative 5 is smaller, so we have that on the left side. So x is greater than negative 5. So we're going to have that. And then C, this is x less than 1. So x less than 1. So we would prefer this manner of writing the final answer. So if we write this in interval notation, this is from -5 up to 1. Okay. So let's just finish this. The interval notation of this will be open parenthesis. This is not included. And then up to 10 over 3. But 10 over 3 is included, so use a bracket.